Hello children, so today we are going to start a new chapter, triangles, and this is example 1 sum, page number 113. So these are basic sums children. If you go from these sums to exercise sums, then you will feel it easy. So this is the diagram. They have given that OA is equal to OB. Now if you see, OA is this and OB is this. Always remember children, in the diagram if something is given like this is also 1 dash and this is also 1 dash. That means this is equal to this. OA is equal to OB. Now these are two dashes. That means what does it say? That this OD is equal to OC. Sometimes they will give in the question, sometimes they will give in the diagram. But you have to understand if this is 1 and 1 dash means OA equals to OB. 2 dash means OD is equal to OC. And what does these two lines means where these angles are made? What do they mean? Here if you see AB and CD are two lines and they are meeting in a crossway, multiplication sign, and we have learnt in 6th chapter that if two lines meet, then vertically opposite angles are equal, up and down, right and left. So now here this is up and down. That means this angle is equal to this angle. So how will we write? To prove that these two triangles are congruent, this triangle is congruent to this triangle, you need 3 points. So our first point is already given. OA is equal to OB. That is our first point. You can write that this is given. Second point, OD is equal to OC. This is also given. So this is your second point. Now we have found out with this diagram that these vertically opposite angles are equal. Now how will you name these vertically opposite angles? Always remember children that if you are starting from A, now AO. Now here what is AO? AO is going like this, AO. So here that side you have to tell BO. Okay. So AOD is equal to, you are going from right to left. So this also will be right to left. So AOD is equals to BOC. So this is the way you have to correctly name it. AOD is equal to BOC. So these are, what is the reason for this children? Vertically opposite angles. So now you have given 3 names. So once you know 3 points, you can prove that this is equal to this. But by what test are they equal? Okay. So how will we find out? See, this is side, this is angle, this is side. So if I take the upper triangle, it comes like this shape, V shape. Side, angle, side. Or if you take the down triangle also, it is side, angle and then side. There should be no gap when you are naming anything. This is side, angle and side. Or if you name like this also, it is side, angle and then side. You should not jump. So you can say by side, angle, side, AOD is congruent to BOC. This is done. Now you have to prove that AD is parallel to BC. Now if I make this triangle as, how can you prove some two lines are parallel? This is parallel, AD is parallel to BC, you have to prove. So suppose this is the diagram, this is B, this is C and AD. Okay, so what I am going to do now is, I am going to tell that this is congruent to this, alternate interior angles. So if I prove alternate interior angles are equal, that means the lines are parallel. So what is this name in the middle? What name is there? O. So if I say OAD is equal to OBC, then they are alternate interior angles. But I should check whether they are forming like that. You see, OAD is equal to OBC. Why? Because they are congruent parts of congruent angles. So we say it as CPCT. What is CPCT? Congruent parts of congruent triangles. That means if this is equal to this, then if I make the same pattern, O in the middle, from O in the middle I took, and then going towards my left and right, O, A, D. Same way, O, B, C. So this will be equal because I am taking the same pattern. And here, if I put this name here, OAD and OBC, they are forming alternate interior angles. That means this CPCT is also alternate interior angles. And if alternate interior angles are equal, that means BC is parallel to AD. That's all. Hope you understood children. We'll see next class, next sum.